Hi everybody. In this video I want to show you how to control the fan operations using Arduino and temperature sensor. I have used a 4x4 matrix keypad to set the necessary parameters. All the set points are saved in the EEPROM so that data is not lost in case of power failure. I have used a 1.3-inch OLED display to monitor the temperature and set points. In addition to this, a Bluetooth interface is also available here, by which we can also monitor the temperature of the engine hall, change the temperature set points, and control the fan operations remotely. Here the fan will start if the room temperature exceeds the set point high limit, and the fan will stop if the room temperature goes below the set point lower limit. In this display there are 8 number of pages that alter automatically one after another. As per our requirement, we can open any page by pressing the buttons of this keypad. For example, if we press 1, then page 1 will be open. If we press 2, then page 2 will be open. If we press 3, then page 3 will be open. In this way, we can open all other pages as per our requirement. Now let's see how to change the set points. To enter the setting menu, we have to press the equal sign. So let's press the equal sign. Now to set the parameters, we have to press any of these buttons. So let's press 1. Here set lower limit for unit 1 inlet temperature. That is, we have to set the lower limit for ventilation fan number 1. Lower limit is the limit at which the fan will stop. So let's put as 28.50. Okay, lower limit has been set. Now set the upper limit. Let's set the upper limit as 33.60. Okay, the upper limit has also been set. Now we have to set the parameters of ventilation fan 2. Here the lower limit is 28.50. Okay, lower limit has been set, and the upper limit is set to 33.60. Thus the lower limit and upper limit of the second fan has also been set. Now let's see whether our new set points have been valid, have been changed accordingly. Here we see that the set point lower limit is 28.50 and higher limit is 33.60, and also for the second fan, the set point lower limit is 28.50 and set point higher limit is 33.60. So the settings have been updated. In the same way, by pressing the other buttons, we can set parameters for other ventilation fans. In the description below, I have provided all necessary information, including circuit diagram and coding, so that you can implement your own project. If you like the video, then to get these types of videos in future, please subscribe my channel. Here there are 8 sensors to control 8 ventilation fans, of which 4 ventilation fans are used as inlet ventilation fans, and the remaining 4 ventilation fans are used as exhaust ventilation fans. This is the PT100 temperature sensor. This sensor can sense the temperature from 0 degree to 100 degree centigrade. Here for this PT100, 0 degree corresponds to 100 ohm and 100 degree centigrade corresponds to 138.5 ohm. Thus, the change in resistance for 0 degree to 100 degree centigrade is equal to 38.5 ohm. Therefore, in order to build up and simulate this PT100, I have used a 38.5 ohm variable resistance and a 100 ohm fixed resistance. Here, this is the RTD transmitter. This senses the variation in the resistance and transmits signals in the form of milliampere. I prefer this because I need to transmit the signal to long distance without noise. For a resistance change of 38.5 ohm, the milliampere changes from 4 to 20 milliampere. Let's see this. As we change the resistance, we see corresponding change in milliampere. The milliampere changes from 4 milliampere to 20 milliampere. Also we see that if we change the resistance, that is, if the sensor resistance changes, then there is a corresponding change in temperature. But now the problem is that the milliampere signal is not recognized by the microcontroller. Therefore, I have used 250 ohm resistance in between grounding and each signal cable. Here from this equation we see that V is equals IR. So for 4 milliamp signal, 4 into 250 ohm is equals 1 volt, and for 20 milliamp signal, 20 into 250 ohm is equals 5 volt. Thus, for temperature change of 0 to 100 degrees centigrade, the voltage changes from 1 to 5 volt, which is read and scaled by the microcontroller. Here this is the ventilation fan circuit, and this is the three-phase ventilation fan. This is the three-phase supply voltage, and these two buttons are manual on-off push buttons. We can control the fan operation without microcontroller by pressing any of these manual buttons. Let's turn on the fan, turn off, again turn on, turn off, turn on the second fan, turn off the second fan. Turn on all the fans together. Turn off all the fans together. Here, to avoid complexity, I have simulated 4 ventilation fan operations instead of 8. Otherwise, the page size will be very large and it would be difficult to demonstrate. This is the on relay and this is the off relay. These two relays get command from microcontroller to operate the fan automatically. Now, if we increase the PT100 temperature and the temperature exceeds the set point high limit, then the ventilation fans will start. And if we decrease the PT100 temperature and the temperature goes below the set point lower limit, then the ventilation fans will stop. Let's see this. We have increased the PT100 temperature above the set point high limit, and the ventilation fans have started. Let's decrease the temperature below the set point lower limit so that the ventilation fans will stop. Okay, ventilation fans have stopped. Here from this section, the microcontroller gets information about the status of the engine, whether the engine is on or off. This is used to reduce the auxiliary consumption. The control logic is so designed that the fan will operate as long as the engine runs. As the engine stops, after a certain delay, the ventilation fans will stop automatically to save energy. Anyway, the fan can still be operated manually regardless of engine condition. If we increase the PT100 temperature, the ventilation fans will start, because now the engine is in running condition. And now if we stop the engine, then the ventilation fans will stop after a certain delay. Okay, ventilation fans have stopped. Now if I start the engine, then ventilation fans will again start. If you do not need this type of interlocking, you may skip this circuit. Now I will show you how to monitor the temperatures remotely via the Bluetooth interface. Here this is the Bluetooth interface. I will also show you how to set the parameters and start stop the fans remotely. So let's enter the Bluetooth terminal and select the PC. And let's go to the receiver. Here from this receiver I can get the temperature information of the process, and this is the temperature corresponds to the temperature of this display. If you compare this temperature, you will find that the temperature is identical to that displayed in this Bluetooth terminal. Thus, we can also monitor the temperature remotely via this Bluetooth interface. Now let's go to the terminal. Press C. Let's set SPRIF and enter. Then I will get all information together. Okay, I have gotten all the informations together. Now let's change the set point of fan number 1. This is SP1. Okay, I will have to put the lower limit. Lower limit is set to, for example, 37.2. Okay, lower limit has been set successfully. Now set the upper limit at which the ventilation fan will start. For example, this is 32.3. Okay, the upper limit and lower limit of fan number 1 has been set. Now let's check this. Check whether the setting has been updated. Here we see that the lower limit is 27.2 and the higher limit is 32.29, and that is 32.30 that I have already set in the terminal. Now let's start and stop the ventilation fans remotely via the Bluetooth interface. One, on. Ventilation fan 1, turn on. Okay, ventilation fan number 1 has been turned on. On, off. Turn off ventilation fan number 1. Okay, ventilation number 1 has been turned off. Now this is the second ventilation fan. Let's turn on ventilation fan number 2. Okay, ventilation fan number 2 has been turned on. Turn off ventilation fan number 2. Thus ventilation number 2 has also been turned off. Now let's see the parameter setting physically. Here I alter the pace to see the changes. Now let's enter the setting menu. Here I press 1 to set the parameters of ventilation fan number 1. The lower limit of ventilation fan number 1 has been set. Now set the upper limit. Okay, the upper limit has been set. Now let's set the parameter of ventilation fan number 2, that is unit on exhaust ventilation fan. Okay, lower limit has been set. Now set the upper limit. Okay, upper limit has been set. Now let's go to unit number 1 to see whether the setting has been updated accordingly. Okay, setting has been updated properly.